65. Today we are throwing things. So if you had taken physics this year, this would be easy. If you're stuck in chemistry, I'm sorry. I'm stuck there too. Anyways, moving on. Today we are talking about falling body problems. So things are falling and we are modeling it using calculus. Now, two things you should know. The acceleration due to gravity is negative 9.8 meters per second squared. Why is it negative? Because it points down, right? Okay. In American units, for whatever reason, it is negative 32.2 feet per second squared. Now, with this information, what we can do is we can generate velocity and position or height equations for something that's falling. Simple enough. How do I get velocity from acceleration? Antiderivative, the integral, right? Because the derivative of velocity is acceleration. So if I integrate this, I get negative 9.8t plus c. And that c we are actually going to call the initial velocity. Then, if I want position, oh yeah, calc 2 plus c, people. Plus c. Plus c. Every time. Every single time. Oh, okay. I'm done? Alright, that's all. Okay, how do I take the integral of this? What's the integral of negative 9.8t plus v naught? Remember, v naught is a number. So when I integrate it, I'm going to treat it as if I'm integrating a number. What's the integral of that, Michael? So what's the integral of t? Over? T squared over 2. So since I'm going to divide that by 2, I'm going to do negative 4.9 t squared. What's the integral of v naught, Israel? Remember, it's just a number.
1.
Sure, let's call it 1. What's the integral of 1? T. Right, because if you have the derivative of like 2x, you get 2, right? So if you integrate 2, you get 2x.
Oh.
Right? So this is v naught c plus what? I integrated, so plus c. In this case, the c is our initial height. So I'll call this, let's do y.
How many problems do we have to do again? 20?
I don't know. It's in the thing.
There's like 70.
I know.
Yeah.
It's on the classroom. So these are your falling body equations. So your velocity is this one, your acceleration is that one. Now, if we use the 32.2, you get a whole different set of numbers. Okay? So here's our problem. An object is dropped from a height of 2,000 meters. Since we're in meters, I can use those. Begin with the acceleration function and develop the position function. How far above the Earth will the object be 20 seconds later? So they are also asking what y of 20 is. That's fine, we'll get there. How do I start? Well, we begin with the acceleration. So acceleration is negative 9.8 meters per second squared. If I integrate that, I get velocity at time t. What's the velocity function? Same as over there. Okay, what's our initial velocity if it is dropped? No, velocity. What's our initial velocity? If you drop something, what's its speed right there? 0. Right? Unless you push it or you throw it or something, its initial velocity is 0 if it's dropped. So V naught is 0. That's fine. How do I find the position? You integrate velocity. What's the integral of velocity? Position. What's the integral of negative 9.8 t? Doing all right?
What's the what?
Integral of this. What do we got? Plus. We took an integral, so plus c, which is the initial height for 2000. So that is our position function. Not too bad. Now they want to know what's the position at 20. So I'm going to plug in 20.
14.
That equals 40 meters. Fun? Straightforward, probably. Okay, this time we are throwing a ball with an initial speed downward of 40 meters per second.
Is this how physics is?
Yeah.
This,
Well, this is good physics. The physics
Oh,
we have to do is super watered down because people don't understand calculus.
Gosh, you took forever.
I
It
know.
was so.
I know. Like we just developed all the equations. That was it. It's done. No.
That class was easy.
Okay, moving on.
That was a fun
Chemistry's
class.
easy too, though.
Chemistry's easy. I'm doing fine. It's the freaking naming
Naming.
quizzes. I just am lazy though. It's my fault. Because I don't want to take the time to memorize.
Yeah, I didn't either, and then I forgot it, and then I had to teach it, and then I had to actually learn it. Go figure. All right, cool. So they say it's thrown down with a velocity of 40. So is this statement accurate? Not to be confused with the car. That's an Acura.
you just said the statement is it's thrown
Yeah.
at that speed.
So is that true?
Yes.
So over here we said that if gravity points down, it should be negative. So then if it's thrown down, it should be negative. Because it's pointing down. Okay?
I thought it was like the speed.
Yeah.
Okay.
Okay? Thrown downward with a velocity of 40 meters per second from a height of 2,000 meters. Sweet, still meters. Okay, they want us to find the position function, and then what will be the position after 8 seconds. That's what we're solving for. First step, acceleration equals. Ooh.
Thank you.
Okay, integrate both sides. Integral of acceleration is velocity. What's V naught?
Negative 40.
It is plus C, which will be negative 40.
Initial velocity.
So that's my initial, right? If I plug in 40 and t equals 0, I'm set. Now, I'm going to integrate again. Integral of velocity is position. That equals, when you integrate this,
Plus r minus 40 t plus initial. What is initial? What's 2000?
position.
Position.
Or height, not physician. That's somebody who heals people.
Initial position.
Position, not physician.
Switching up is on you.
Okay, that's that. So then, how do I find y of 8? Well, you plug in 8. And that equals some number. Okay. That's your lesson. Begin on the homework.